Welcome to Unpacked, the podcast that examines how technology is reshaping business and our world. This season we're unpacking generative AI. Our show is produced by Think Tank at Lab 45, Wipro's Innovation Lab. My name's Stuart Black, and I'm joined by the voice of the show, Think Tank's innovation lead, Arvind Ravishankar. Arvind, it's Earth Day today. I can see you've got your leafy green plants behind you, and is that a green shirt you're wearing today? What does Earth Day mean to you?
That's right. Stuart, I'm glad you picked up the color. It is. It's an olive green. It's my favorite shirt, and I did wear it for Earth Day. I love that question. In fact, I think among all the questions we've discussed, what is Earth Day mean to me is such a priceless question. Obviously, my views on this continue to evolve and change. I'll tell you my most current thinking on this topic, especially in the age of artificial intelligence, and given that we are running a podcast on generative AI, right? So we don't know, in reality, we don't know today if this new signs of intelligence that generative AI is showing, its ability to translate, its ability to summarize, understand context, give you creative responses. The truth is, at the base of it, nobody knows how it works. That is the truth. We all have, the most intelligent people have good intelligent guesses and understanding, but the truth of how it works is something nobody knows. So, and also our concepts of intelligence evolves, right? It's evolving over time. So in a world in the future, if AI does become conscious, right? In that future, if AI does become conscious, AI will become the most intelligent being on this planet. Today, humans are the most intelligent on this planet, right? On intelligence, we are like far exponentially higher than a chimpanzee, which is the next most intelligent.
So, some of us are, Vin.
No,
I count myself
AI,
out.
if AI becomes conscious, and if we hit what they call AGI, that will surpass the intelligence of most human beings, will become the most intelligent thing. And the way we treat our planet today, I think the reason we treat the planet this way is because we are more intelligent than all other beings, right? So we use our intelligence to survive and thrive. And there's nothing wrong with it. As humans, I mean, every other species would have done the same thing if it had become the dominant species. However, I think as we grow, we are becoming more intelligent and aware that what our actions today and the way we are living is destroying most other organisms in our planet, right? And wiping down forests and species. So the question is, tomorrow, if AI becomes more intelligent than us, would it treat us the same way? So for the first time, we are facing this question where the roles are reversing, right? In 10, 20, 30 years from now, if AI does become more intelligent, and if it looks back at how humans are treating other species on the planet, the question is it okay for it to treat us the same way? Is it okay for us to walk around with a leash on our necks? Is it okay for AI to destroy all homes to create data centers that will allow it to process more power, right? So this is a very important question that we all have to be asking, is the way we treat our planet today is definitely going to tell a new form of intelligence what we do and what we respect. And if you think that you want to be treated the way you treat others, then it's a question to reflect on. I don't think there's a clear answer to this, but at least I want to throw out the question. So this is what I'm pondering, right? When I think of Earth Day, when I think of my everyday life, or even with my own pets, my interaction with animals and nature, the questions these days I ask myself is, how am I treating the environment? How am I respecting and thinking of the environment? Because I know tomorrow another intelligent being is going to treat me the same way. So If that's my perspective. A little heavy, I don't know,
but
it's how I'm looking at the world.
It's a fascinating insight to what's coming, and what you're saying is we've got to be careful about the example we set, because this creation of ours could
you
come
said
back.
It so much more eloquently than I did. Yes,
it's a case of AI
exactly
karma.
Right. That's AI karma. I love that word. We should tag that word, AI karma. That's exactly right.
Fascinating.
What's going to be our AI karma?
We'll be talking more about Earth Day and all the environmental issues associated with that as we go. But I should tell you, next coming up, we've got Arvind's deep dive interview with Dr. Eng Lim Goh, who is Senior Vice President of Data and AI at Hewlett Packard Enterprises. Arvind, can you tee this one up for us a little bit?
Sure. I think, as you know, there's many angles to artificial intelligence, and one of them is its impact on the environment because of the processing power, the heavy, intense processing power, and all the resources that it takes up. And Dr. Goh is an expert in this area, and I think he's been studying this in his organization. And so we're going to unpack that and understand what they're doing, and also unpack his wisdom in this particular topic.
Sounds great. Before we get to that, though, we're going to look at a couple of stories about artificial intelligence that connect somewhat with Earth Day. First up is a new product that's seeking funding on Indiegogo. It's an air purifier that uses AI to enhance indoor air quality, called the Brivy Pro Air Purifier. It basically uses sensors to monitor air quality, detect impurities and allergens, then filter the air as required, as well as providing real-time data via an app. The spiel they give is that the filter system is made of moss and coconut, and it claims to offer eco-friendly air purification while reducing your carbon footprint. So Arvind, first of all, would you consider backing this project?
I don't think I would endorse any particular product or brand, Stuart. However, what I want to talk about is what they're trying to do, right? The use of artificial intelligence to improve air quality. That I would love to comment on. And if you think about it, when you have a really large, today air purifiers are sort of smaller devices, right? Where you have it in the corner of a room or in a small space. But in a future where if you want to purify the air in your entire home, that's going to be very energy intensive, right? And in those situations is where I see AI play a bigger role, because in those situations, you want to turn on the air purifier or calibrate the level of purity, etc., to a point where it makes sense for the home. You don't want to blanket purify the air in the entire home if there is good quality air in certain parts of the house or whatever the situation is. So there's a way to calibrate, and that calibration of air quality is where I think AI can help, because it can do it dynamically and it can do it with a lot of intelligence, right? So in this particular application, I'm not an expert on air quality, so I'm not able to determine if AI is really useful or not in this particular application. So I guess the company will have to justify that to its consumers and tell them why AI is needed for a small air purifier. Maybe there's a good reason for it.
Well, let's run with that. There are at the moment lots of companies jumping on the AI bandwagon with solutions to problems we often didn't know we had. How can we tell the useful stuff apart from others that are just doing a bit of AI washing, if we can use that phrase?
I love that question because it gives a plug for our podcast. Listen to Unpacked. Understand. Actually, it also goes back to the episode with Dr. Anastasia. We did this episode where we spoke about the psychology of AI and the importance of people being educated about artificial intelligence, right? So today there's so much knowledge out there in the world for free. YouTube videos, podcasts, articles. Find experts in this area and get yourself educated. That's the best way. Knowledge is your number one defense against any washing, whether it's greenwashing, AI washing, whatever it is. Get educated and trust your instincts.
That's well taken. Good point. Our second story today is a regular annual feature, the 30 under 30 list for European manufacturing and industry. And this year's slant has been how sustainability is at the heart of Europe's industrial innovation. This year's list includes rising stars working across a range of interesting areas, from recycling plastic waste to robotic delivery networks to creating prototypes for space habitats. And many of these projects combine AI on the one hand with an environmental solution on the other. And they say they're laying the groundwork for a sustainable future in line with the European Green Deal's carbon neutrality goal for 2050. So, Arvind, my question to you is, what can we learn from this new generation of entrepreneurs who it seems are combining AI with their new thinking to address some of the most important environmental challenges of our time?
That's a lovely question, Stuart. I think the conventional wisdom in business schools in the past used to be that the purpose of the existence of a company is to satisfy its shareholders. That used to be the wisdom. And I think more and more the new philosophy is that the existence of a company is not just for its shareholders, but for all its stakeholders, its employees, the society it lives in, right? The environment from which it takes resources. So to see these entrepreneurs at such a young age focused and understanding this, right? And working on problems and showing the world that, hey, I can have a successful business on this area of sustainability where I look at the overall stakeholders and not just the shareholders. And also being recognized for it, 30 under 30, I think is amazing, absolutely amazing. So kudos to those entrepreneurs. And I think we have a lot to learn from them, right? The first thing is that business doesn't have to be all about money. There's more to it. And business leaders can actually have a bigger impact than financial returns.
Arvind, can you just tell us a little bit more about what we're focusing on in today's interview with Dr. Goh?
Yeah, absolutely, Stuart. I'm going to dive in on and unpack what it really takes to power artificial intelligence and run artificial intelligence. And AI is going to grow. The quote is that in the next 4 to 5 years, there will be 2.7 million AI servers shipped in the market. And the growth of AI data centers is exploding, right? So with all of that growth, what could be the impact on the environment? And we can't stop growth. It's not a good idea. You have to, it's natural to grow. But as we grow, what can we do in that growth to keep the environment safe? That's going to be our conversation. And looking forward to this because of Dr. Goh's reputation in the market and his expertise, right, in this particular area and all the amazing things his company is doing in the space.
Great stuff. It sounds like an ideal conversation for Earth Day then. So without further ado, here's Arvind's deep dive interview with Dr. Goh. Our think tank focuses on researching emerging technologies that will shape your future. From generative AI to exoskeletons, we study the impact these technologies will have on business, humanity, and our planet. And through our podcast, newsletters, and social media content, we have a direct line to a truly global emerging technology community. So if you'd like to find out more about the impact these technologies will have on your business, then reach out to our team at lab45thinktank.com.
Hi, welcome to another episode of Unpacked, where we talk about generative AI and we look at generative AI from many different angles. And today we're going to talk about generative AI and sustainability. As a business leader, in today's world, it's really important that you're not only charting your business for profitability and growth, but you're also charting it with a conscious mind of how the planet is going to be affected by this and what would consumption do to our planet. And so this is a topic that is broadly referred to as sustainable AI. And today I have an expert on this topic to talk about it. I'm really excited because it's not often we have such a luminaire in our midst. And so let me tell you a little bit about our guest today. He's a senior vice president at Hewlett Packard Enterprises of data and AI. He was also a principal investigator at the International Space Station. He won the Singapore Visionary Award in 2010 In 2005, he was named the world's 25 most influential CTOs by Information World. His work for Stephen Hawking included a symposium invitation to introduce the discoveries of Professor Saul Perlmutter, who won the Nobel Prize in 2011 in physics. He's a PhD from Cambridge University, and his bachelor's is from Birmingham University. He holds 11 patents, and 4 of them are ESG related. Please join me in welcoming Dr. Eng Lim Goh. Dr. Eng Lim Goh, super happy to have you here today.
Oh, hello. Thank you for having me.
How are you doing?
Fine, thank you. Yes.
Where are you calling in from today?
Today, Singapore.
Lovely, lovely. Lovely. We're super excited, and we know that we have a lot to cover, so I'm going to dive right into it. So, Dr. Goh, most business leaders are very excited today about artificial intelligence and generative AI and what it could do for us as humanity. But we also know that there is another side to generative AI, which is the energy consumption. So today I want to do a little bit of unpacking with you on why is it important for business leaders to be conscious of the topic of sustainable AI and what should they possibly know about it, right? So let's start with the first basic question. Why is it even important for someone to consider sustainability when it comes to AI?
Many factors, right? One, there is the responsibility part. Corporations, many of them have their net zero goals mapped out, right? That's number one. Number two, this new generation, right, of employees coming in. In fact, during interviews, the fact of how conscious the company is in sustainability does come up. So it's also something that these talents look at. Number three is economic, right? In the supercomputing world where we originally came from, right? And now we need supercomputers for these huge Gen AI large language models. Where we came from, initially it was the ability to pack as many calculations, capability into the machine as possible. But as we move forward, eventually we realized that the gating factor was power, right? The largest machines we've built is of the order of 20 megawatts, right? Single machine able to run a single job, like forecasting the weather or doing fluid dynamics of a jet engine, or even to run a huge large language model. It was the power consumption that became more and more a concern. Right? The operating cost, if to just give you an idea, right? If it was the home 10 cents per kilowatt hour bill that you get, 20 megawatts is $20 million a year. Imagine opening up your electrical bill and it shows 20. Now, of course, these large data centers get bulk electrical billings, right? But to give you an idea of the operating cost of these things. So generative AI, say large language models, the frontier models, meaning those big ones, right? Trying to become bigger and bigger. They started being hundreds of billions of connections, just like brain connections. And then they grew to 1 trillion, right? And now they are talking about multi-trillion connections model, right? And as you grow the number of connections, amount of power required to run them, not just train them. To run them is also a lot of power, right? Where you have hundreds of thousands of users, querying, prompting these large language models. So, many reasons for sustainability. First, of course, is the responsibility part. Second, is the new talents, right, coming in. Not that the older talent weren't conscious of it, but you tend to get that being one of the top questions asked by new talents, right, as they decide whether to join your company, right, and three, economic reason.
Yeah, I think that's well said. In fact, we do studies at our think tank, Dr. Goh, and one of the things that staggered us was that when we looked at data centers, which is where AI is housed, um, if you keep the current status quo as it is, and you forecast out to 2050, our projection is that if nothing changes, data centers will emit the same amount of carbon dioxide emissions as our entire planet does today, just data centers alone, right? And so that staggered us, which is why we got really serious about this topic too. So love it. Now, before we dive in a little bit into what is being done about this, I also wanted to ask you if it's beyond power, right? What about areas like when you talk about sustainability? Do you also consider areas like water? I know data centers consume a lot of water, or do you also consider things such as deforestation, natural resources? Would all that be also a part of sustainable AI?
Oh, absolutely right. So the overarching theme should be resource efficiency,
Yep,
right?
I love that. Yep.
With energy efficiency, and taking that backwards would be power efficiency being a big ticket item. But water use efficiency, what do you do with your servers when they go out of commission? That's a resource, right? You don't want e-waste them. Right? So it is a holistic consideration which we put under resource efficiency. So we spoke about power efficiency and therefore energy efficiency. We'll probably talk a little bit more about detail later, but you asked about water efficiency. Yes. These huge cloud data centers, one of them actually published their numbers, right? Just one of their data center, huge one, they have many, but one data center, huge one, would be evaporating something like one Olympic-sized swimming pool of water per day.
Wow.
That's a lot of water, right?
Wow.
Now, why? Why? Well, why is this? Why are they evaporating this water outside the data center? Well, the answer is when the heat from the data, huge amounts of heat, right? We're talking about tens and tens of megawatts of heat. All right, coming out of data center, it needs to be cooled down before that water is being sent back, right? Pipe water is being sent. So what they do to cool it down, they blow fans at it on the outside, and if it's still not cool enough, they spray water on it. It's just like us when we are really hot, we sit in front of the fan, and if we can't get cool enough, we spray water on our faces, right? We keep spraying and it evaporates the water. Yep. Imagine that's evaporation. The evaporation actually sucks out the heat. Yeah. Right.
Yep.
So that's how they cool their data centers by spraying water at that heat. So one way to have resource efficiency for water is to design your computers on the inside of the data center to mitigate as much hotspots in the servers as possible, so that you don't need that high margin overhead of having cold water or cold air blowing inside your data center. Some data centers, some computers are cooled by water direct, some computers are cooled by air. But a lot of them run at much cooler temperatures in order to deal with the fact that there are hotspots they need to deal with. So what we do with our highest end system, our supercomputer system, is they are water cooled, but we work very hard to engineer away the hotspots so that we don't need as much margin in coolness. So we can run the inlet temperatures to our data centers into our servers at, say, 32 degrees centigrade. That's roughly about almost 90 Fahrenheit. Yeah. So when you can take in water at 90 Fahrenheit or 32 centigrade, and then when it comes back out from the servers at 39 centigrade, 32 rises up to 39 because the computers heat them up, and then you send the 39C outside, right? You can actually cool it without spraying water. Just fans will do. Provided, of course, on the outside, the temperature is, say, at 35, 36 centigrade, which most of the days in many places, you have temperatures below that, and therefore you don't need water then.
Makes sense.
So when you don't need to spray water, you save the evaporation, and then you save water. Yeah,
makes sense.
And
it's like
you do it by just removing hotspots. Yeah, By
Yeah,
well,
and
I shouldn't use the word just, right? It's a lot of engineering effort to do it. So basically, you pay upfront to engineer away hotspots so that you pay less later in water.
it makes sense. And I think
Yeah.
more and more it starts to make sense on why placement of your data centers is such a huge topic and where you place them, right? In fact, I hear data centers today under the ocean and space. There's a lot of work going on. We'll dive into that a little bit if we have some time. And the third part that you alluded to, the first is power consumption. The second is cooling and water consumption. And the third is, one of the things we also learned, Dr. Go, is that today only about 13 to 15% of infrastructure in a data center can be recycled. Everything
Mm.
else goes into electronic waste, right? And so, and if you move into this new world where AI is going to dominate, you're going to have a huge amount of replacement of infrastructure. Could you talk a little bit about that and bring some awareness to that topic?
Yes, e-waste, right? It's an issue that is of great concern, right? To to recycle, to try and extract recyclable material from it, uh, uh, needs a lot of care, right? So for e-waste, what's more sustainable than e-waste is to recycle. But in
Yep.
fact, what's more sustainable than recycle is reuse.
Reuse. Yep.
So we go for maximum reuse first at HPE. So that's part of the reason why we've built two technology renewable centers, one in the US and one in the UK, totaling something like 450,000 square feet. Huge. Right? Last year, 2023, we took in something like 4 million pieces of IT devices. And on the server side, we reused 86% of them. Basically, by reuse, I mean we refurbish and then remarketed. It benefits the customer that's upgrading to new equipment, because their old equipment, they can still get value back from them because we try to remarket them, right? And then it also helps with the sustainability part tremendously, because in terms of resource efficiency, there's no e-waste, no recycling, totally reuse, so 86% of it for servers, and then much higher percentage for mobile devices, and in the 90s. Now 86% reuse of our servers, basically refurbished and remarketed, and it's labeled when we ship it out from these technology renewal centers. They are packaged as HPE certified pre-owned. Right.
Wow. Okay.
Yeah, and 86% reuse, which means the remaining is recycled. Very
I
very
love it.
little e-waste, right? Very
I
little.
love it. I just love
Yeah,
it. And Dr.
yeah.
Go, if our audience wants to learn more about this, are there resources they can tap into at HPE that will help them understand this a little bit better? White
Yes.
papers, experts.
Yeah, just key in technology renewal centers.
Okay,
Yeah.
perfect. I love that.
HPE, it comes up. Yeah, this is a very important part of HPE's sustainability targets. Yeah.
Brilliant. So, Dr. Go, we covered a little bit about three aspects of sustainability: power, cooling, and reuse. So let's do a little bit of a deep dive into the energy consumption,
Mm.
power, because that's a huge topic. Maybe you could start by telling us a little bit about, a quick 101 on why is AI so power hungry? Where does the power go? Is it in the training, or is it in the operations, or is it both?
Mm. Initially, the thought was that training is going to consume huge amounts of energy, which it does, right? I mean, if you have a trillion parameter model, you want to put 10 trillion words. They call it tokens, but let's use words, easier to visualize. 10 trillion words through this thing in order to train it, right? Every word firing up a trillion parameters, and therefore all the computation in the GPUs going on. That's a lot of energy, right?
Mm.
Yeah.
Mm.
But then later we realized, once we deploy these models out right? And then you have many users prompting it. You end up firing these trillion parameter model a lot more often.
Got it.
Some even
Got
are
it.
thinking maybe the ratio is 1 to 10, right? I mean, you 1x in training and 10x in inference, or even more, right? So both, yeah. But in particular, inference, you've invested hundreds of millions of dollars to train these huge models. The question is, you want to make use of them to amortize that cost a lot more, and that's where inference comes in. That actually brings us to another topic of using the right size model, but perhaps that would be your next question.
Actually, you're right. It does segue into that topic nicely. But I wanted to share a fact with you before we dive into that. I read today that on average, today there are 9 billion searches that happen every day. So, from what you just told us, if everything gets converted to AI, that's 9 billion times you're going to try to inference AI models in their operations, right?
Yes.
That's a huge, huge amount of energy.
And if you
So,
multiply, there's another multiplier there, right? So do you say 10 billion, right?
9 billion. Yeah, you could
Okay.
say 10 billion.
Let's just say 10 billion. But then each one of the 10 billion is going to query it, prompt it with, say, a question with 10 words.
Yeah.
and then the LLM will then reply with 100 words.
Oh my God.
Right?
Oh my
Right?
God.
Every word, right? We're talking every word here. So 10 billion multiplied by, 110.
Yeah, it's the 100,000.
Yeah. So you can see how these things adds up. Yeah. Every time a word goes through, the parameters gets fired up. Yeah. The connections get fired up. Yeah.
And you know, in enterprise applications, which is what you were alluding to, as business leaders deploy AI, the choice of models is a
Yeah.
really important question, right? Could you talk a little bit about that?
Yes,
Should people use a model?
That's a great question, right? That's a great question. So pick the right size model. Pick the right model. I shouldn't say pick the right size model. Pick the right model, right? So these frontier models, right, the biggest ones out there, from OpenAI and from Anthropic. Amazon's support is investing in Anthropic, and then Microsoft investing in OpenAI. Perhaps we can remove this part. But in any case, these frontier models, right, are huge, and and there's another group, right, trying to instead of building bigger and bigger models, trying to instead of investing their R&D into scaling bigger and bigger, they are instead trying to invest their R&D in squeezing the most out of every connection they have. Right? So they're not trying to go big. Yeah, they're going reasonably big, but then investing in squeezing the most out of them. So instead of going a trillion, they say one of the approach they take is to say stay at 100 billion, or even stay at 10 billion instead of 1,000 billion, a trillion, right? Stay at 100 billion or even at 10 billion, and see how far they can go with this. First approach. The second approach is a mixture of expert approach. And that is, instead of firing up all the connections, only you compartmentalize your connections into expert areas and put some smarts into it. So depending on what word comes in, they only fire up the right portion of that network.
Oh, excellent. Okay,
Yeah.
got it.
So typically they fired up about 1/4 of it. Right? They try to compartmentalize into, the common one now is compartmentalized into 8 compartments. And then at any one time you fire up only 2. You pick 2 to fire up, right? These 2 methods combined, right? We've seen one that is giving quite a strong proposition, and that is, would you accept an 18% drop in accuracy for 100 times reduction in power? Now that makes you start thinking, right? So there's actually one proposition out there, right? You don't get everything for free, right? I mean, there's a drop
Sure.
in performance in terms of accuracy, but then you get 100x drop in power consumption. Now, for example, at the edge, when the intelligent edge comes about, perhaps this is something that is quite interesting, right? Yeah, out at the edge, right? 100x reduction in power makes it really start to make you think that I can deploy this at these device level, small device level edge, right? That are maybe even perhaps battery operated, right? 100x today, hopefully 1000x going forward, right? At 20%, 18% reduction in accuracy, perhaps it's okay to make very quick real-time decision in terms of general direction to start with, while the accurate answer comes from the cloud a little later.
Yeah, directional accuracy.
Yeah,
makes sense.
Yeah. So these are now there's yet now another huge R&D group, right? Looking at squeezing the most out of what they have.
So I know
these two paths, are the ones they're looking at.
Got it. And I know, Dr. Goh, that this is still early stages in these learnings, but you've covered with us today the choice of models. You covered with us the way you architect your AI, train it, inference it. You've also covered with us the concept of edge versus cloud when it comes to your AI architecture. Anything else for our business leaders to consider when it comes to energy consumption of AI?
Yeah, I think measurement, right? In order to optimize for resource efficiency, in say, for example, energy efficiency and carbon footprint, right? You need to be able to measure. So we put a lot of effort in ability to measure the customer worldwide data center energy footprint in real time. It's under the HPE GreenLake capability. Sustainability Insight Center. We have HPE Sustainability Insight Center. And it monitors not just the energy consumption from the server level all the way up to data center and then across data centers worldwide, right? It also gives you the energy cost, right? And also the carbon footprint, so that if you are part of if you have a net zero goal, you can then be able to look at this and work on different parts of your infrastructure in order to get to your goals. This seems like something obvious, but you want dedication into accurate measurement and also flexibility in that measurement. So we've not implemented it yet, but we've been receiving requests from customers who say, I have contracts that say that my energy cost varies in a day, across the day, right? When there's a peak electrical usage, right? The energy company charges more, and when it's low usage, charges less. Or when there's lots of solar power because sun is shining, it charges less. And when there's wind is blowing, yes, but when both are not, right, the cost goes up. So for those who are OPEX operating cost conscious, right, they may actually want to adjust their data center usage, right? Usage in their data center based on electricity costs. So all this is down to ability to measure first.
I love it. Yeah, and if you don't measure, you don't know the reality of what's happening. Dr. Goh, talk to us a little bit also on the hardware side, right? We covered a lot on the software side in terms of how it impacts performance. There's a lot of work going on today in terms of new GPUs, new CPUs, new computer hardware. And from what I'm reading, in the next 3 to 5 years, the expected shipment of AI servers, 2.7 million units of AI servers are going to be shipped out in the next 3 to 5 years. And so that's a huge amount of hardware. Talk to us a little bit about that. Is there research going on making the hardware more efficient? And what should our audience know about choosing the right hardware?
Yeah, it's It's a research topic, definitely, and also an engineering topic, right? Let's start with the research topic, since you brought it up first, and then I'll talk about engineering. Both are trying to find a way to reduce the power consumption for the work these GPUs do. GPUs with CPUs do. One is, GPUs consumes power, right? I mean, multiple hundreds of watts, yeah. And they may be driven. The easy way is to drive them at maximum power all the time. But more and more now, research is being done to make more efficient use of dynamic power. It has been around, but using it has been difficult. Implementing it and using it has been difficult. Dynamic power means you adjust the power of your GPU based on the workload. Yeah, best would be within a task at certain times when the GPU doesn't need to run at full power because there's a lot of data movement, right? You need to put more power into data movement than the compute, right? You would then start vary the power based on workload need. It is difficult to implement, and even more difficult to use, because you need to make an estimation as to make an inference, make a prediction as to when to lower that power at the right time, right?
Got it.
And people are also looking at ways of machine learning to adjust, to try and make that prediction. Yeah, that was also part of the reason why a laptop company, right, has performance cores and efficient cores. Yeah, if you look at one of the laptop companies, they have these, right? Meaning that's actually my laptop. Yeah. So instead of trying to vary the power dynamically, it says that given a task, if it is a backup, I put it on efficient cores. If it is a mouse click, put it on a performance core because I want the response to be immediate. Right?
Got it.
It goes to show that it is difficult to implement dynamically, but research is going on to get there. Right?
Yeah.
The second part to that is data movement. What's being not considered enough today is that the performance of the compute, is going up tremendously fast, right? But the bandwidth that feeds the compute is growing much slower. Right? In fact, some estimate that it's going always 2x behind what it should be, right? And part of the reason is this. Well, I'll just give you a simple example, right? You got GPU and CPU, each with their own memory, and then therefore separate chips, separate package. Therefore, a lot of copying of data goes on there, and there's a lot of energy consumed when you copy across a distance. So what they're doing is trying to bring the two closer and closer together, and that's why you see some of the newly announced GPU have two of these chips put side by side in one package to try and reduce the energy consumption.
Got it. Well, it's actually reassuring to hear the amount of work going on, even on the hardware side. One of the things I'm taking away, Dr. Goh, from all the insights you've shared with us, it sounds like this topic of sustainable AI is everybody's responsibility inside a company, right? From the operations team to the hardware team to the software architect to the person who's choosing the AI models to the use cases. Everything influences finally the concept of sustainable AI. It almost feels like everybody's responsibility. I love the word responsibility that you framed at the beginning, right? It is our responsibility to think about this. So would you say that it has to be a mindset shift inside an organization across all levels?
Yes, absolutely. Top down, bottom up.
Exactly, top down, bottom up.
Bottom up with these new hires, new talent coming in. As I always emphasize, the existing talent have the same responsibility mindset. Is that the new talent asks that question right up front? Yeah, bottom up. But the top down also, right? Very same thing. This, you see, how for decision makers, right? in the past, it was how much performance do I get for my workload for this cost, right? Capital expense. If it was, you can convert that capital expense to operating expense using the cloud approach, or the hybrid cloud approach, or us with HPE GreenLake. Right? But there is also a big growing operating expense portion, and that is your power consumption, right? And also what do you do when you upgrade with your old equipment. But let's look at power consumption. So one way for the top-down mindset would be when making acquisitions, look at this is a term we used before, TCO, that concerns factors in the energy cost. Right? So a server might cost a little bit more, but over time, let's just say use a 3, 4, 5 year horizon to calculate TCO. If it is much more efficient, it may be worth it in terms of TCO. Look at that look at TCO that includes operating costs of energy consumption going out.
It totally makes sense. Yeah, take the long-term view. Don't take a short-term, immediate.
And even if the operating cost was factored in a cloud pay-per-use model, there is also that one would also, if you're not doing on-prem, right, or colo, you also want to query in terms of the power consumption used by whoever is providing it to you. Why? There's one metric, right? If you have a net zero goal as a corporation, we picked one of the most comprehensive and I would say toughest initiative to join, right? And that's the SBTI, the Science-Based Target Initiative. Why is it tough? It requires that you not only consider your own carbon footprint, you have to also consider your customers, the people you supply to, carbon footprint, and also your suppliers' carbon footprint. So the entire value chain. Right? To give you an idea of how tough it is, 8,000 companies worldwide join SBTI. It's part of SBTI, but only 9%, got an approved net zero target year. 9%. We are one of those, right? So when you start to consider, you can't just say I myself have a good carbon footprint, right? You also want to consider whoever is supplying compute to you, whether they are also they also have their net zero goals, for example.
Yeah, it's first of all, it's super encouraging to hear that 8,000 companies joined SBTI, and 9% was a selection finalist. Dr. Goh, there's so much more I want to cover with you in terms of cooling and also in terms of reuse. So I think maybe a second episode is due, and I hope you'll join us once more in the second episode so that we can dive further in. On this particular episode, you've given us so many insights to think about when it comes to sustainability and AI. Any last advice for business leaders overall, right, as they think about their AI deployment in the next couple of years? Any last parting words of advice for our business leaders?
Well, I've covered, you've actually summarized it very well. So, and the only point I'll bring up in terms of resource efficiency, one other point is that today a lot of these data centers were built using a cloud native architecture, and that is many small workloads running on many servers, many on many. But generative AI large language model is very, very different. Let's call it not cloud native, but AI native, right? Where you have one big workload, like a supercomputing application, really. One big workload running on many servers. So instead of many on many, you got one on many. And given this, if you want, you can actually build a system that's much more efficient, knowing taking advantage of the fact that it is one on many, because things come in bulk. Yeah. Analogy I'll draw is that in an AI native system, because we know things come in bulk, it is much more efficient to haul a big load using an 18-wheeler truck than a convoy of 30 pickup trucks. Yeah. It's actually more energy efficient. Yeah. So because we know LLMs are huge, right? We can build systems that are for LLM. And it turns out HPC, high performance computing supercomputers, are in the same way. And that's how we also can get more efficient. So it goes back to the other point about knowing that it might cost a bit more upfront, but in the end, the carbon footprint is smaller.
Wow, I never knew you could match hardware with a type of LLM. That is so interesting. That is so interesting. So, Dr. Goh, is it okay for our listeners to reach out to you if they have more questions, if they want to dive deeper? For some of our business leaders, is it okay if they reach out to you on LinkedIn or other forms to explore this further?
I'm not on LinkedIn, interestingly.
Oh,
let me
okay.
see. englim.go@hpe.com.
Great. Thank you so much for that. So I encourage our business leaders to reach out to HPE and Dr. Go. You can clearly see the amount of research that they're doing in this area of sustainability and AI. And Dr. Go, that gives us a lot of hope, right, for this, because it's such an important topic, and I hope more and more people pay attention to it. And we're definitely looking forward to having you again in our podcast for a part 2, where we'll dive a little bit more into cooling. We'll talk maybe a little bit about liquid data centers in space, which is a new topic I'm hearing a lot about in terms of management of cooling. So I would love to explore that. And also your work on the International Space Station. Let's talk a little bit about that in our next episode.
Yeah.
Thank you so much.
Yes.
Yeah. Go ahead, Doctor.
Thank you for the time. Yes.
Yep. Thank you so much.
Arvind, fantastic interview, as always. And as always, I'm going to ask you if you can pick out some of the key points and takeaways that we should all be thinking about
this time, because I want everybody to really listen in to what Dr. Go said. But yes, I can summarize it. I think, when it comes to artificial intelligence, the resources that AI uses can be broken down into 3 parts, right? The power it consumes in order to process all that information, the cooling that it takes, because as you process all that information, tremendous amount of heat is generated. So the cooling it takes, and the third is all of that electronics that is used to build AI. Not all of them today can be recycled. In fact, I think the statistic is 13% of e-waste today is only recycled. The remaining 87% goes into landfills, right? So these are the 3 most important ways. Now, obviously, we didn't cover some of the other things like deforestation, etc., but I think these are 3 most critical areas. And it's really encouraging to hear that he and his team are doing deep research in this space. And within these 3 areas, I think the most important key takeaway I heard for business leaders is that all of these things are connected, right? So if you ask someone, how do you reduce the power consumption of artificial intelligence? It starts even with the type of AI models that are being deployed. Are they being deployed for the right use cases, right? So if you're using an extremely high performance AI model to solve a very partial, small, marginal use case, then you're wasting all that power for something that is trivial, right? So right from how you're selecting your use cases, and going back to the conversation we had on AI washing, right? Don't just put in AI so that your stock price goes up, right? Put it in because it's meaningful. All of those things, right from there up to how you run your data centers, to how you manage, everything is important in this particular world, right? So I think that was the key takeaway, Stuart.
time for Arvind. Thank you so much, as always, for a great interview and great insights. I don't know what you'll be doing now to really get into the spirit of Earth Day. I might head off to the forest and, who knows, even put on a green shirt, just like you. If you like our podcast, please like, subscribe, or tell a friend. I'm Stuart Black, and see you next time on Unpacked.